Hi, my name is Vlad, and this is my presentation on document databases overview. So, what are document databases? Document databases is a data storage system designed for obviously storing, retrieving, managing, organizing, processing data that's organized in a document-oriented fashion. This is also known as semi-structured data. Document databases are one of the main categories of NoSQL databases. So a lot of, or pretty much, it shares all the similarities with NoSQL because it's a subcategory of it, obviously. Um, of a specific, some examples of NoSQL databases. I'm pretty sure they're NoSQL, but they obviously have document database capabilities. Are Amazon, Dynamo, Microsoft Azure, MongoDB, and IBM Cloud. And XML databases are a very specific example or subclass of document databases that are optimized to work with XML documents. And I'll go into that on the next slide. So how do they, let's just talk about a little bit about how they work. So document databases are sort of inherit the idea of a key values like storage system, key value pairs. Um, the difference between NoSQL and document databases, however, is that in NoSQL, the data is essentially invisible to the database. But for document databases, um, they rely on the internal structure of the document. So how does the document actually look to be able to extract certain metadata that the database engine then uses to be further optimized. And let's just talk a little bit of the history of document databases. So I'm going to start talking about how relational databases have been around for over 4 decades. They've worked really well with uh, f- they worked really well in their prime in the sense that data used to be really static, really boring, really simple, but it's 2020 now and technology is growing and advancing at a really rapid rate, and so is data. So is the complexity of data. NoSQL databases and document databases are much more popular nowadays because they're flexible, they're cost efficient, they're just a much better alternative to relational databases because they're just able to do more for cheaper. So, what's the structures and how do they work? I'm first going to talk about the extensible markup language, which is XML. It's a markup language that essentially the whole point of it is that you're able to read it as a human, as if it's just English, and then the computer is able to read it as if it's code. So here we have two examples. On the left, we have an XML document, and on the right, we have a JSON document. And it's the exact same document, just written in the two different sort of document database, um, codes, let's just say. There's much more, but I believe these are the two most popular ones. And as you can see, they're much easier. You can read them pretty easily, just as if it's like a paragraph, and computers can read this as if it's code. So how are like what are the keys of these document databases? The keys are essentially just unique identifiers for the document, for this single document. This key could be an ID, like a number, six-digit number, eight-digit number. It could be a string, a couple of words that sort of describe what this document is. It could be a URL if this documents or if this database is um, web-based. It could also be a path if your database is local on your own machine. And I'll get into that a little bit more in a second as well. Finally, another defining characteristic is the values of document databases. And what are the values? Obviously, the documents. Um, One really interesting thing about document databases is a lot of them have APIs, which are which are tools that programmers are able to use to much easier access certain data. For example, if I wanted to find all the data with this value, with this extension, I could use the API to find every single document with this value and this extension, which makes it much easier because in relational databases, they just don't have that type of functionality. And how are these document databases organized? So there's three main sort of ideas of organization where you have collections, which are groups of documents which could be divided by like the year, the time period of which the document was made, anything like that. Tags are essentially data about the document. So it's essentially metadata. It could be like the size of the document, the time it was made, the time it was made, and when it was like put into the database, like maybe a sort of little description of what it might have if it's just like mostly string values or mostly whatever it may be. So that's what tags are. And finally, directories are a tree-like structure um, that organize your entire database. So for example, if you have your database on your local computer and your keys are the path, right? You can have a folder with your database, 12 folders for each month of the year, and then four folders within each of those 12 folders for each week of that month. And then you'll have your documents within those final week folders, right? And the key would be the path, and this is like a tree-like structure, right? It's based on path in this sense, but you could have a URL as well. But what are the advantages and different disadvantages, also some differences between document and relational databases? So they're really unlike. Relational and document databases are w at no means whatsoever similar. This is because relational databases, as we know, store data in separate tables that have to be defined by the programmer before any data is even created. So you have to create the bones before you can start adding anything onto it. Document databases have, oh, sorry, additionally, relational databases can have multiple instances of the same metric value. However, databases store all the information for a given object, segment, person, whatever, in a single instance in the database, which is all stored in that document. And they're all different from each other. I mentioned unstructured data before, and this means that, like I said, you can build your application without having to define the structure or the bones of the database. In a relational database, you're required to make these bones the structure before adding any data to the database. You can see that this is really hard because nowadays there's so much data that can't possibly account for everything from day one. You know what I mean? Because there could be just like random things that just pop up, and it could be really hard to change because relational databases are very expensive, very time consuming. Also involves downtime of the service or like interruptions. People can't use the service when you're changing the structure of your relational database. However, like I said, document databases much easier. You can just add, remove, replace, do anything much faster, much cheaper. Um, finally, um, document databases are also able to encompass every type of data type. For example, text, pictures, voice recordings, biometrics, videos, emails, photos. I don't know if I said that, like anything. However, relational databases are much more strict in the sense that a lot of the data has to be very similar to each other. So like only strings and integers or only pictures, you know? Finally, relational databases are vertically scalable, which means that they require a single server to host the entire database. And like RAM on your computer, the more you want it to do, the more expensive it is, the more RAM you need to buy. Same thing here, the more expensive, the bigger service, the bigger server you need to pay for. It's more expensive. It has to have less latency and this and that. On the other side, document databases and NoSQL databases in general have scale horizontally, which means that they can have multiple servers, and they could have these servers in different geographical locations around the world, which therefore can provide a better service experience because they'll experience less latency. And finally, NoSQL databases and document databases, but NoSQL databases are more part of an open source community, meaning that programmers can come together to create something and everyone can use it. On the other side, relational databases being used for the last 40 years have obviously been a way for companies to profit off of, essentially meaning to use some sort of relational database, it's it's blocked behind licensing fees and it's closed source and it's much harder to access. That's my presentation. Thank you for listening.